before we even start, what are the numbers that I gave you yesterday? We wrote them at the top of the paper, huh?
2357.
2357. Okay, 2357 are the numbers you need to check. If it can be divided into, and they're the only numbers that you're allowed to circle for groups. Okay, 2, 3, 5, and 7. So starting with this one. So we have a number on the outside. Okay, and so that's the main difference from yesterday to today. Okay, is if there's already a pre-number on the outside, and it really doesn't change much. But my suggestion to you would be to immediately, before you even start the problem, drop the number down. That is the number one mistake kids forget to make, is that they'll do all the problem and then they forgot that there was a number from the outside to begin with. Okay, so I always just draw me a little arrow down and say -5, and I can go ahead and put the square root. Okay, because we know that we're going to have, I shouldn't say square root, but in this case it is a square root. Okay, when is it not called a square root? Yeah, okay, when there's a number on the outside, okay, this index, when it's anything other than a 2 or nothing, okay? So if it's a 3, 4, okay, it's called what? What's this called? It's not called a square root. What is it called? A radical, okay? So 392, what are some factors of 392? 2 and 196. 196. On your calculators, whenever you get the 196, you don't have to hit clear. You just say divide and then say by 2 and it equals. Divide by 2, it equals. 298. 98. 2 and 49. And then the 49 is going to be 7 and 7. Okay, what is our group number? We can take stuff out in groups of 2. Okay, so who is allowed to go? A group of 2s. Anybody else? And a group of 7s. Okay, we write 1, 2 for this group on the outside. 1, 7 for that other group. Who is not allowed to go? This last 2. Okay, this guy that's underlined right here. And where does he go? Inside, okay, that's Lucas, remember, and he has no friends.
Okay, is that
Okay, so what do you do with all of these numbers? You multiply them. So what is -5 times 2 times 7? -70. So you're going to have -70 square root of 2. Okay, so this is what I was talking about. See this 5 here in the beginning? That was from the very initial. And so if people forget that, what number would they get on the outside? 14, which makes a problem wrong. Okay, so my suggestion to you would be to immediately, before you even start, drop that problem all the way down, that number all the way down to the end. Okay, if you do that, it's fine. It's nothing really different than yesterday. -5 times 2 times 7, which is 10. -10 times 7 is -7. But you just multiply them all. Okay, so 3, we're going to drop this -2 all the way down first. And we can put our square root with a what? With a baby 3. Okay, now, sometimes you're going to get something where it has a negative on the inside. Okay, I can tell you right now, just pretend that that's a positive 189 and put the negative on the inside at the end. Okay, you cannot take a square root of a negative number. Eventually you can, and it's called complex or imaginary numbers, but we're not going to do that. So you're going to put the negative back in the square root. So you're just, on your calculator, going to say 189. So what are some factors of 189? 3 and what? 3 and 63? 63, and then we got 7 and 9, and 3 and 3.
oh, I stuck with 3.
That's okay, you can. And I did that on purpose. So normally most of you guys would try 2, right? And 2 doesn't work, and you try 3. Now, but how many, did you still get 3 3s and a 7? Yeah, and you should. So no matter what numbers you guys pick, like if you chose to do something other than 3 and 63 from the gate, you should still get a 3, 3, 3, 7, okay? And so, some people like, trying to think of a number, 24, right? You could say 2 and 12, or some people would just write down 3 and 8, okay? That's fine, you're gonna get the same numbers as that tree branches out. The only reason I do it with the lower numbers first is so it makes that like line going down, and you can kind of see, because then all your threes probably match up, whereas mine don't, right? Yeah, okay, so, who can go? What's our group number? 3, so who's allowed to go? A group of 3, so we got 1, 2, and 3. Where does those guys go? Outside. Who's not allowed to go? Huh? Lucas. And what is Lucas? A 7. Okay, so, and then what do we do with the outside? Multiply, so -2 times 3. -6. You draw your radical with a baby 3, and then we put the -7 back in there. Okay, my one critique for today that some of you guys were not doing yesterday, I should definitely be able to tell when I look at your paper that that is a baby 3. It's called the index of the radical, and it lets us know that we took stuff out in groups of 3 or groups of 4 or groups of 10, whatever. So make sure that that definitely looks like a baby 3 and not a big 3. $27. What are some factors of 27? 3 and 9. And 3 and 3. What is our group number? 3. Huh? 2. You're fine. But a group of 3s can go. I said yeah, and then I was like, wait, no. Okay, so we're going to draw our square root. Who's going on the outside? 3. Who's not allowed to go? Okay, which is a 3.
You made 2 of the same problem.
I know. It's okay. Okay, so 7 is the same. And I put it on here on purpose. Do you need to make the tree? This factoring tree, do you need to make it? No, why not? Yeah, okay. So some of these, let's think smarter, okay? If you already have the tree made for the inside of the radical, then don't make it, okay? So this one's just 3 square root of 3. We already know that. We did 27. If there was a negative on the outside, then just throw the negative on there, okay? Square root of 16. We already know that it's 4, okay? If you need to make the tree, okay? I'm going to make the tree just to show you what happens when there's nothing inside the radical, okay? So if we did 16, we'd get 2 and 8, 2 and 4, 2 and 2, right? What's our group number? 2. We can take them out in groups of 2, okay? So we got 1 group, 2 groups, okay? Where do they go? Outside the radical. Okay, so we got a 2 and a 2. What do you do with those? You multiply them. So 2 times 2 is 4. This is what I want to talk about. What happens when there's nothing inside the radical? Well, first of all, let's talk about what does that mean? Okay, so we could say me and Madison could go, right? And Patrick and Braden could go. Okay? Who cannot go? No. Everybody went. Okay, so if we look at this, everybody went. All that's saying is there's nobody left inside the house. And if you think about that, are there times when no one is at your house? Yeah, right? Everybody's gone. That's okay. However, do you normally see a problem like this as an answer? What is your answer? It's just 4. Okay, so I don't want to say don't be goofy, but don't be goofy and leave the radical on there when you know that it's not supposed to look like that. Okay? So there are going to be times where there's nothing left inside the radical, and that's totally okay. Okay? We already know that a square root of 16 is 4. We don't say 4 radical nothing. We never say that. We say what's the square root of 16? And you say 4, okay? But on these ones that you already know the square root, just write down the answer. You don't have to make the tree, okay? Okay, what do we need to do first? Drop down to 5. Okay, when there's a number on the outside, that should be the first thing that you do. So we got 5 and the radical. What's the square root of 36? Or factors of 36? We already know that the square root of 36 is what?
6.
It's 6, right? So, but if you need to do the factoring, go ahead. Okay, your answer, I can tell you right now, there should be a 6 on the outside and it should be a 30, but let's see if that happens. So, 2 and 18, 2 and 9, 3 and 3. Okay, so if we were to do this the long way, you'd have a group of 3s and a group of 2s. Okay, well, what is 2 times 3? 6, and we still have that 5. And 5 times 6 is 30. Okay, do we write 30 square root? No, there's nothing left inside the radical, so it's just going to be 30. Okay, but this is another one. If you know that this is going to be 6, you don't need to do all this work. Okay?